Okay, today's lesson is on chapter 1.3. If you look at your notes, you'll notice that there are 3 parts to it, although we're only really going to officially cover 2. But before we get into the meat of today's work, we got to take a look at a new type of process that we're expected to understand. We have experienced the first type of number, but we haven't officially called it by its name. The first type of number is called a square. The square of a number is found by multiplying it by itself. So the square of 3 is found by taking 3 times itself, and so therefore the square of 3 is 9. The square of 10 is found again by multiplying it by itself, which means that the square of 10 is 100, just like the square of 7 is 49, just like the square of 9 is 81. Again, the square of a number is found by multiplying it by itself. The new number we have to learn is called a square root. The square root of a number is the opposite of a square, which means that it's found by finding the number that multiplies by itself to make it. So, as we know the square of 3 was 9, that means the opposite direction, the square root of 9 is 3, because 3 times 3 make 9. So again, the square root of 9 means we're looking for a number that multiplies by itself to make 9, which is 3, because 3 times 3 is 9. The square root of 100, you're looking for a number that multiplies by itself to make 100. That is 10, because 10 times 10 is 100. If you were doing the square root of 36, again, you would be looking for the number that multiplies by itself to make 36, which we know to be 6, because 6 times 6 is 36. Alright, quick examples on the back for this. Again, remember to pause and get your notes down the way you need to. The square root symbol looks kind of like this. It's just a check mark with a part over it, but again, if you're looking for this, that is read the square root of 16, which again means you're looking for something that multiplies by itself to be 16, which is 4. Here, the square root of 25 means I'm looking for something that multiplies by itself to make 25, which is 5. The special thing about the square root of a fraction is that you can separate it to be 2 square roots over the top and bottom. And so when we look at that, the number that multiplies by itself to make 4 is 2. The number that multiplies by itself to make 9 is 3. So the square root of 4/9 would be 2/3. Now one more thing about this. If you look at your calculator, mine is a little different because it's not the one that's distributed by the school. If you look above the x squared button, which is right by the 7 in this part, you see a square root symbol, which means the way you get to that, because it's green, is you hit second x squared. So for yourself, make sure you know how to pull up this x squared, and that will at least give you your ability to do the square root of 16. Enter, gives you the answer of 4. Or you hit second x squared, 25, which gives you the answer of 5. And again, you want to practice this because you want to be able to do these things on your own. Even this one, the square root of means hit the square root. And don't forget on this calculator that n over d gives you a fraction. And there's your 4/9, arrow down to get your 9, and when you hit enter, you see that your answer is 2/3. Alright, so again, square root just means what number multiplies by itself to make that number. What we're here for, though, really is just real numbers. Real numbers are numbers that actually exist. I know it sounds simple, but it's really true. The opposite of real numbers are imaginary numbers, which are numbers that don't exist. But again, real numbers are numbers that actually exist. Every number in this chapter, and pretty much in 2, 3, 4, and all the way up to maybe chapter 9, 10, or something like that, is going to be a real number. So don't think about anything that's not real. We're not going to expand you that far, but our job is to classify each type of real number that actually exists. And just so you know, again, for your notes, there are 5 types that you need to know. I am not going to do so much to give you the textbook definitions, because you can always Google those and look them up in the dictionary, but I'm going to try to give you examples of things as you write this that help you make sense of what each type is. The first thing is natural numbers. Natural numbers are numbers that you use to count naturally. If you were going to start counting the number of red shirts in the room, the first thing you would do is say 1, then 2, then 3, then 4, which means the first natural number is 1. Notice there are no decimals, because nobody counts and says 1, 1.5, 2, 2.5. We go 1, 2, 3, 4, and we continue on to what we call infinity, which is the largest possible number up there, but that would take forever to get there. Whole numbers, again, there is an official definition, but this is how I think of whole numbers. It is just natural numbers with a whole added. And to me, the whole is 0, because 0 looks like a whole, so therefore your whole number starts at 0, 1, 2, 3, 4. So again, a whole number starts at 0, which is the whole, and then 1, 2, 3, 4, and again it goes all the way up to infinity. The numbers that you're used to seeing are integers, which is positive and negative whole numbers. That means take the whole numbers and flip them on both sides, which means you have the negative biggest number ever, which is negative infinity, all the way down to negative 3, negative 2, negative 1, 0, 1, 2, 3, and again all the way up to infinity. Notice in these three sets there are no fractions, there are no decimals, because they don't belong in those three sets. Fractions and decimals don't come along until you get to rational numbers, which again, there is a official definition. I guess it says that you can write it as a fraction, m over n, but again, the way that you can actually identify them, rational numbers make sense. Again, if somebody is rational, that means they make sense. The way I view it is rational numbers can fit in a box. Now there is one rule that breaks it for irrational, but let's just talk about this for a second. 0.2 is a rational number because I can fit it in a box. See that? 3/5 is also a rational number because I can fit it in a box. That is a fraction. Negative 9.3232, if that's all that there is also rational because I can fit it in a box. The number negative 6, rational, I can fit it in a box. 0, rational, I can fit it in a box. Now, if you remember bar notation, that means that this is 9.6666 ... which means it goes on forever. But the fact that I can write it in bar notation means that in bar notation, I can actually fit it in a box. So that actually is rational. So anything that can be repeated, so 2.3233232 going on forever, is actually rational because you can write it using bar notation as 2.32 repeating, which as you see can fit into a box. Again, rational numbers are numbers that you can easily just fit into a small rectangle so that you know that it makes sense. Again, that's rational numbers. Now, irrational numbers, of course, are the opposite. They are just not rational. Here's how I explain this. Square root of 5. When I do square root of 5 and I convert it, by the way, whenever you do this and you want the decimal form, the conversion button is this little arrow down here. It looks like this. That means converting between your forms, so you hit that button and you see that the decimal you get is 2.236067978. Anytime you get a decimal that does not that goes all the way to the end of your screen and has no pattern, that means it goes on forever with no pattern. If there is no pattern, then we cannot use bar notation. If we cannot use bar notation, that means it does not fit in the box. That is irrational. The number E. E is actually the code for a number that exists. I'll just show it to you. This is the decimal form of E. 2.718281828. I don't think it even repeats, even though it looks like it does. E. Anytime a number is so crazy that they have to simplify it down to a letter or a symbol, that means that that number is also irrational. And then the last type is this 2.345123897. Notice there is no pattern, and these three dots means it goes on forever. That also cannot fit into a box. It is not rational. Okay? So the essential question is, how do I make sense of each type of number that exists in mathematics? Well, the easiest thing to do is study your notes like I recommend, 15-30 minutes a night, and learn the common sense connections that make each type of real number group. Like I said about natural numbers, whole numbers, etc. After a while, you just get used to it. So your examples on the back say to classify each value by circling the types that apply. Here's what we do. We look at 2/3 and we say, would I naturally count something as 2/3? No, because I go 1, 2, 3, 4, so it's not natural. Whole number, no, because fractions and decimals are not included. Integer, no, because fractions and decimals are not included. My question for rational versus irrational is, does this fit into a box? Yes, it does, so it is rational, which means it can't be both. It cannot be both of these parts, which means it's either rational or irrational, and because it is rational, that means it cannot be that. So the only thing you can use to classify 2/3 is that it is rational. Look at the number 13. Is that a number I would naturally count to? Yes, there could be 13 people in a room, so it is a natural number. Remember that whole numbers are just natural numbers that have a whole or zero added, which means that this is also a whole number because it doesn't have any decimals or decimals or fractions. Remember that integers also don't have decimals and fractions, and they're positive and negative, which means that it's also an integer. In terms of whether it's rational, can this number fit into a box? Yes, it can. And if it is rational, that means it is not irrational. So 13 actually has a bunch of groups it fits in. Negative 7. Will we ever count to negative 7? I don't think so, because it starts at 1 and it goes up. Remember that whole numbers start at 0 and it's not negative, which means no there. But integers do contain negative numbers, which means that works. Rational means does it fit in the box? The answer to that is yes, and so therefore it is rational. And because it is rational, it means it is not irrational. Be careful about square roots, because you don't really do square roots as square roots. You want to convert those into decimal form, and so you want to type in square root of 15 and convert it to a decimal. But notice as you look at this, there is no pattern to this, and it goes all the way to the back of this window, which means that these numbers go on forever. Because these numbers go on forever, that means that it's irrational. I know for a fact we've never counted to square root of 15. I know for a fact it's not a whole number, because that decimal is not a whole number. It's got a decimal in it. It can't be an integer, and again, if it's irrational, then it cannot be rational. Alright? And then square root of 1, again, do the square root of 1 in your calculator just to make sure you see what the decimal version of it is, and notice that the answer is 1, which means that because it is actually 1, after you simplify it, it is natural, because you would count with that. If it's natural, it's also whole. If it's natural, it's also an integer. And because the value of 1 can fit in the box, it's rational, and it is not irrational. And then the last example you're looking on that is pi. And as I said in your example, any value that is so complex that it needs to be simplified down to a symbol is an irrational number. Again, once it's irrational, it can't be anything else, because all those numbers are rational numbers. Again, an irrational number is so crazy that they just simplify it down to something. Remember, they haven't even figured out where pi it ends yet, because it just goes on forever and ever and ever. So pi is definitely irrational. Now again, part 3 is not an official lesson, but just listen and make sure you understand what's going on here. There is one more topic that must be briefly discussed, because you're going to be asked to put numbers from least to greatest order. So just think of the number line here. The number line itself goes on forever in both directions. With 0 being here, you notice that there's negative 1, negative 2, negative 3, and it keeps going that way. You notice that it goes 1, 2, and 3, and it keeps going that way. But if you notice something, if this represents the smallest and this represents the biggest number, notice that your smallest number is going to be not negative 1, but negative 2, 3, 4, 5, 6, 7. It could be negative 100, negative a million, negative infinity is going to be the smallest. So again, notice that the smallest value is the biggest negative. Based off of this rule, negative 3 is smaller than negative 2, because it's a bigger negative. Whenever you think negatives, I think about debt. Would you rather owe $3 or $2? Because you'd rather owe 2, that means that this is smaller, so that's something you got to be careful of. This holds true for every negative number. The biggest negative is the smallest value. So what you're going to typically see is multiple choice questions on this. So what I'm going to show you today is how to use common sense to answer it, and we'll use other strategies later. But the general rule is that all values can be converted into a decimal, so before you do any kind of ordering, make sure you convert everything to a decimal if necessary. So if you're given this question, which is on the bottom of your sheet, first thing I want to do is convert them all. Remember, that's a fraction, so we fix that by doing 1 divided by 4, which gives me 0.25. So on my paper, I would put the decimal form of that number. Negative 2 is already in decimal form. That's a number. Square root of 8, type it in, and convert it using this conversion button, and you get about 2.828. Negative 7 halves, again, that just means take 7 divided by 2, or negative 7 divided by 2, which is negative 3.5, and 1.3. Now here's the thing. Typically, ignore the fact that we just did that. Typically people look at this and they see so many options and they feel overwhelmed, and so they just kind of guess, but you really don't have to guess if you use common sense. Look at your first option, A. Is it possible that 1/4 is smaller than a negative number? I don't think so, because the smallest number should always be a negative, which means it cannot be A. The next thing we have to do is determine whether negative 2 is the smallest or negative 7 halves is the smallest. And again, as you look at this, negative 7 halves is negative 3.5. that is bigger than negative 2. And remember the rule I said, the bigger negative is actually smaller, which means negative 2 is not the smallest, which means it cannot be b. Now we're down to these options, so negative 7 halves, negative 2, 1/4. The last question is, which one is bigger out of square root of 8 or 1.3? And because I've converted these to decimal form, I can look at this and see that negative or square root of 8 is 2.828, 1.3 is 1.3. So the bigger number out of those is square root of 8, which means that should be the biggest, which means out of the options I have left, it has to be D. Alright, so again, you're going to have about 5 of those on your homework for Math XL, so just be sure you take your time on those. Make sure you practice using your logic on it to work your way through it. Just don't get frustrated, because again, those questions are going to be on your quiz. They're also going to be on your test, and I think they're easy enough to do. Like I said, it's common sense that it couldn't be that one. Once you understand that this is smallest, it can't be that one, and then you just kind of figure out which one makes the most sense from there. But your final thought is that in order to classify a number properly, the easiest way to do it, or the best way to do it, is check the qualifications of each type. But what that means is that you must remember the types of real numbers and what makes each of them special. For example, natural numbers, again, you can naturally count with the numbers 1, 2, 3, 4, 5. Whole numbers begin with the whole, which is 0. Integers are positive and negative whole numbers, so it's all the nice numbers that have positive and negative signs. Rational numbers, as I said, fit in the box. Irrational numbers are the numbers that are just weird, the square roots of numbers that don't work. Also, anything that is so crazy that it breaks down to a symbol. But other than that, go on to your Math XL, work on that, and good luck. Be sure to ask questions on these things, because again, if you get behind, it's going to be a bad situation.